Namaste one and all. In this video, let's we discuss about experiment number 4. In the last videos, actually we discussed about frequency response of inverting and non-inverting amplifier, and then normal voltage follower, inverting and non-inverting amplifier, and then I think the RC phase shift network. Okay. In this session, let's we discuss about the experiment 4, that is nothing but design and analysis of operational amplifier based voltage comparator circuit or voltage level detector circuit and zero crossing detector or ZCD. Okay, these are all the components required and aim of the experiment. Okay, theory part, procedure, and then theoretical circuit diagram. Okay, okay, get into my notes. Okay, here we need to discuss voltage level detector or voltage comparator. What do you mean by voltage comparator? Here we need to compare the voltage level. Okay, yes, this is the circuit diagram. Here I'm going to use inverting voltage comparator. Inverting is nothing but I'm going to give the signal generator supply to the inverting terminal. Okay, and then plus VCC minus VEE as usual. 6 is nothing but output terminal. Here I'm going to connect the CRO or oscilloscope, and then I'm going to give sine wave input for the inverting terminal with the help of signal generator. Okay, and then here the important thing is this bias network. Okay, this biasing network. Okay, the figure shows the voltage level detector. One of the op-amp input terminal is biased to the input voltage level which is to be detected, and then the non-inverting terminal is biased to VR2 voltage which is dropped across R2. Okay, VR2 is nothing but what is the voltage here we're going to drop, that is nothing but VR2. This VR2 is nothing but reference voltage. Okay, the reference voltage can be set to a level to be detected. Okay, this is nothing but a positive reference voltage. Why positive reference voltage? Because I'm going to connect here plus VCC supply 5 volts, 10 volts, 12 volts, whatever it may be, up to 15 volts. Less than, it should be less than 12 or 15 volts, whatever here I'm going to give. If I give 15 volts, the limitation is less than 15 volts. If I give here 12 volts, means less than 12 volts, like that. Okay, in case if I want a negative reference, means I need to give here negative VEE. Here I'm going to give plus VCC is nothing but positive reference. So that's why I think all of you understood this circuit diagram. The circuit diagram is nothing but inverting voltage comparator. Inverting voltage comparator is nothing but whenever I'm going to give positive sine wave in the input, it will going to give output in the negative form or 180-degree phase shift. Okay, that we're going to observe in the output waveform. Okay, with the help of here we have extra reference voltage. Okay, this VR2 is nothing but reference voltage. So first concentrate on input sine wave. Just concentrate on this input sine wave. Okay, input sine wave. Okay, here and then put one dotted line here. Put one dotted line. Okay, in the middle of your sine wave, positive in the positive off cycle. No, in the negative. There is no dotted line in the negative off cycle. There is no reference because here I'm going to use, here I am actually use positive VCC. So that's why I'm going to use this dotted line in the positive off cycle. Okay, this dotted line is nothing but reference voltage. Okay, reference voltage. What do you mean with this reference voltage? Whenever our input voltage less than this reference voltage, our output will going to be remaining same. Okay, whenever our input voltage greater than reference voltage, then only our output will going to change. Okay, otherwise the output will going to remain same. Okay, I think I'm going to give another example here. Take down here, just observe this this shaded part. Just observe this shaded part here. What is the condition here? Input voltage less than reference voltage, less than reference voltage. Actually our what is the inverting amplifier feature? Whenever I'm going to give positive, it should give negative. Okay, that is the condition. Here, observe here in this negative part, whenever input voltage less than reference voltage, it will going to give positive only. Here also positive, here also positive. Okay, because it is less than reference voltage. Okay, actually it is an inverting amplifier. It should give 180-degree phase shift, but here the condition is not satisfied. So that's why here also positive, here also positive. In case whenever the reference voltage greater than, sorry, whenever the input voltage greater than the reference voltage, then our output will going to change from positive reference, this positive reference to negative reference. Okay, until input will equal to positive only, positive cycle only. Here our output will going to be in the negative only. Okay, this condition is actually correct. Whenever positive supply will going to give for inverting amplifier, it will do 180 degree here. That condition will going to match. Okay, and then another condition here, another reference. Okay, part second part. Okay, whenever our input will reach this reference, here our output will going to change from negative saturation to positive saturation. So okay, this condition, this waveform is going to go on, okay, until the supply is existent. Okay, here negative, here positive, here positive, here negative, here negative, here positive, go on. Okay, this is how our voltage comparator will going to work. Okay, another condition, another condition, very simple. Whenever I'm going to give here, in the last case, I'm going to give positive VCC. Here, negative VEE means here I'm going to observe. In the last case, positive VCC, I put a dotted line in the positive off cycle. Here, negative VEE, so that's why I put a dotted line in the negative off cycle. Okay, whenever our input reaches this negative reference voltage, then our output will going to change from negative saturation to positive saturation. In the last case, positive to negative, negative to positive. In this case, negative to positive, positive to negative. Observe here, whenever our input reaches this reference voltage, our output is going to change from negative to positive. Okay, positive, positive, positive. And then whenever our input voltage reaches another reference, our output is going to change from positive to negative. Okay, this is how our inverting voltage comparator will going to work in the both condition. First condition plus VCC, another condition minus VE. Anyhow, I'm going to show you the practical way how we need to conduct in the multisim software. Okay, shall we conduct the experiment now? Okay, observe here. I'm going to open the multisim software. Okay, I think all of you should know how to connect this. Just observe this circuit and connect directly how our circuit will look like. Okay? Just connect like this. Okay, this is how I'm going to connect. Okay, otherwise you can refer this waveform also. Sorry, this circuit diagram also. Here one thing you need to observe here. Here you need to give uh, ground. Okay, remove this wire and just give observe, you need to give ground like this only. Everything is same, but here you need to, instead of connected directly to this negative part, you just give ground here. That is the changes. Okay, yes. Okay, okay, yes, the circuit is already done. Very easy circuit. I'm not going to do another time. Okay, just observe here. Just here, observe here. Okay, here, what is the positive signal generator I'm going to give to the negative inverting terminal? Means it is a negative inverting voltage comparator. Okay, and then this biasing circuit I'm going to give to the inverting terminal, and then I'm going to give um, uh, reference voltage supply like 12 volts. 12 volts is nothing but 6 volts here divided by 2 VCC divided by 2. Okay, VCC divided by 2. Okay, this is how our circuit will going to connect. We need to connect in the multisim software. Here, A channel I'm going to give to the input, B channel to output, and negative ground. Okay, I think all of you understood how to do the circuit. Okay, next. Okay, run, and then observe the waveform here. Hold, drag here. Okay, yes. Observe here. What is the, just concentrate on reference. Okay, expected reference voltage 6 VCC divided by 2. VCC is nothing but 12 divided by 2 is nothing but 6. Okay, observe here. Observe here. Put it in now. Here. Okay. Yes. What is the input? This is nothing but T2. You need to concentrate on T2. 5.7. This is the approximately equal to 6. Okay. Yes. Put it in the this reference. Okay. In the positive cycle only, we have two references. Okay, first reference, second reference. Okay, yes. In the first reference, 6.2 volts, approximately 6. In the second reference, 5.7, approximately 6 only. Okay, 6 reference only. Whenever our input will going to change after this 6 volts, whenever input voltage greater than this 6 volt, then only our output will going to change from positive to negative or negative to positive. Okay, observe here. Here, observe. This is negative portion. This is negative portion. Whenever our input, the sine wave reaches this reference, then only our output will going to change from positive reference to negative reference. Okay, negative reference. Then this positive, this will going to negative because it's the inverting. Positive, negative, like that. Okay. Then another reference. Okay, whenever our input reaches another reference, 6 volts, then our output will going to change from negative saturation to positive saturation. Okay, this cycle will going to continuous. Okay, yes. Okay, this is how we should understand the voltage comparator. There are multiple types of applications of this voltage comparator. You need to check in the website or internet. You're going to observe many applications of this voltage comparator. Okay, this is a positive reference. In case I want negative reference, means just connect this to negative VCC, VEE, sorry. Okay, observe here. Yes, our reference will going to change from here to positive to negative. Okay, observe here, negative reference. Okay, 6 volts, 6 volts, approximately 6 volts. Okay, this is how we need to check our positive and then negative. Okay, yes, this is a negative reference. In the previous, we saw positive reference. Okay, yes. Okay, this is nothing but our inverting voltage comparator. How to connect non-inverting? Very simple. Here, non-inverting circuit, very simple circuit, same as usual. In the previous circuit, we connect the negative terminal to we signal generator here positive terminal. In the previous circuit, positive to this voltage divide biasing circuit. Here negative to this biasing circuit. Very simple. Okay. Here also same. Whenever our input reaches this reference voltage, positive reference voltage, the output will going to change from negative to positive. In the previous positive to negative, here negative to positive. Okay, this is nothing but non-inverting is nothing but zero phase shift, means positive, positive, negative, negative, positive, positive. But in this case, before our input reaches the reference voltage, our output is remaining negative only, because the input voltage is less than reference voltage. Whenever our input voltage reaches reference voltage, our output will going to change from negative to positive. Okay, this we need to check in the multisim software. Okay, now this is nothing but our non-inverting voltage comparator. Okay, here I'm going to give the input signal to the input signal generator input to the positive terminal. Okay, I'm going to run here. Okay, yes, correct. Okay, yes. Here the reference voltage is 6 because VCC divided by 2. Okay, yes. And then whenever our input reaches, the sine wave reaches this mark, okay, reference voltage, okay, our output will going to change from positive to negative to positive. Whenever our input reaches this reference voltage, our output changes from negative to positive. Whenever our input reaches this another reference, our output will going to change from positive to negative. Ultimate aim is our in the non-inverting voltage comparator, our input is negative, output also negative. Our output is output in negative positive, input also in positive. Like way the cycle will go into maintain the same thing. Okay, this is nothing but positive reference. How to make this negative reference? Very simple. We need to connect this R1 to this negative and then run. Okay, negative reference. Observe here, negative reference. Hold on. Same. Negative reference. Okay. 6 volts, 5.3 is nothing but 6 volts. 6, 5.3, 6.2. Okay. Exactly. Okay. For you don't worry about this input voltage. You can give any value. Here I'm going to give 10. It's nothing but input 20 volts. 20 volts. You can measure. You can measure. Put one scalar in the positive, one scalar in the negative. Observe here. Input is 19 volts. Output is 22. Approximately 20. Output is 24. Okay. Or 19. You can take exact value. Okay. Yes. This is how we need to analyze the voltage comparator. Okay. Thank you. Thank you, one and all.